Hello everyone, let us solve the following. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. Okay, let us understand the problem with the help of the diagram. Okay, so what is given here? A medicine capsule is there. It is in the form of a cylinder, and of course it has two hemispheres stuck to each other of its ends, just like this. See here. So actually the capsule is in the form of a cylinder. Both the ends hemispheres are there, stuck at the ends, both the ends, one hemisphere this side and one hemisphere this side. Okay, so this is the total shape of the capsule, medical capsule, that we regularly take whenever we feel ill. Okay, so it is in the form of a cylindrical shape, and both the sides there is a hemisphere. Okay, and the length of the capsule is given as 14 mm. Mm means millimeters, that we know, and the diameter of the capsule is 5 mm. That is given in, that is provided as the data in the sum. Okay, and the length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Okay, it is given in the data. Okay, so as the capsule is in the form of is in the shape of a cylinder with two hemispheres stuck to its ends, the diameter of the capsule is equal to the diameter of the cylindrical part. It is very very obvious, we can understand both the hemispheres are stuck into that particular cylindrical shape. Obviously it is clear that the diameter of the hemisphere will be equal to the diameter of the cylinder. There is no doubt at all, right? So we can conclude that the diameter of the capsule is equal to the diameter of the cylindrical part and the diameter of the hemispherical part also. Okay, so from the figure it is clear that the capsule has the curved surface area of two hemispheres and the curved surface area of the cylinder. If we take the entire capsule, the capsule has the cylindrical shape. In the middle we can consider, and at the end hemispheres, both the ends we have hemispheres. So from the figure it is very clear that the capsule has the curved surface area of two hemispheres and one cylinder, curved surface area of a cylinder. If we are able to conclude this point, it is very easy for us for solving the problem. Okay, I think you have understood till here, right? So because the capsule, the main aspect, the capsule is in the form of a cylinder to which two hemispheres are stuck into both the sides. We should keep that point in mind. Okay, okay, right now, so what can we write here? Total area of the capsule. We are finding the total area of the capsule. How can we find the total area of the capsule? Curved surface area of the cylinder plus curved surface area of the two hemispheres. Very clear. Okay, it is the curved surface area of the cylinder, and here one hemisphere, here one hemisphere. So in order to find the curved surface area of the total capsule, we need to find the curved surface area of the cylinder as well as two times the curved surface area of the hemisphere. Okay, it is very clear, right? So what is given here? The diameter of the capsule is 5 mm, 5 millimeters. It is given in the data. Okay, when diameter is given, we can write radius. So how can we get radius? Radius is nothing but d by 2. Okay, so radius is equal to 5 by 2, that is equal to 2.5 mm. 2.5 millimeters. Okay, and we have concluded that the capsule shape itself is telling that the diameter of the cylindrical part is equal to the diameter of the hemispherical part. So we can take the radius of the hemisphere also as 2.5 mm. Okay, so it is very clear. Both the hemispheres are, they stuck into this particular cylinder, both the ends, at both ends. Okay, that's why we are taking the radius of the hemisphere also as 2.5 mm. This point should be very clear. When you are clear in this particular point, it is very easy for us. Why did we take the radius of the hemisphere as 2.5 mm? We should be very much clear. Okay, because we know the radius of the capsule is given, then why, how we are applying the radius for radius of the hemisphere means both of them, they both stuck, the hemispheres are stuck into the cylindrical shape, so definitely the radius or the diameter is equal. Okay, so we can take the radius of the hemisphere as well as the radius of the cylinder as 2.5 mm. When we are clear at this particular point, next part is very easy. Understanding this particular point is very important. How can we understand this particular point? This particular point can be understood by the shape of the capsule. When we are able to observe the shape of the capsule clearly, we can easily understand there is a cylinder and two hemispheres both the sides. As they stuck to give a complete solid shape, we are taking the diameter of the cylinder as well as the hemisphere is equal. Here the radius, also the diameter of the capsule is given, and we are applying the same diameter to the cylindrical part as well as the hemispherical part. Okay, so this particular point should be very clear. I hope you understood till here. If you are able to understand this point, next step is only calculation. Okay, that is very easy also, right? Now, so length of the cylinder is also given. We need to find the length of the cylinder to find the curved surface area, right? So length of the cylinder, how can we get? The take again the shape of the capsule. This is middle part is the cylinder, here one hemisphere and here one hemisphere. How can we get the length of the cylinder? It is very clear from the figure that length of the cylinder is nothing but the length of the capsule minus 2 times the radius of the hemisphere. Okay, very clear from this side, right? So we are applying the same thing, but we have been given the length of the capsule here in the given data. The length of the capsule is nothing but 14 millimeters. Okay, so we are able to find the length of the cylinder now. Only here one point. The major part is in the form of a cylinder. Both the sides hemispheres are there. If you are able to picture skew the shape of the capsule in your mind, it is very easy for us to calculate the remaining. Okay, so length of the cylinder we are finding now. How can we find the length of the cylinder? Length of the capsule minus 2 times the radius of the hemisphere, because this side one hemisphere and that side one hemisphere. Okay, clear? So we are finding that particular length. How are we finding? Length of the cylinder is equal to 14. 14 is nothing but the length of the capsule minus 2 into 2.5, where 2.5 is the radius of the hemisphere. Okay, so 14 into 2 into 2, 14 minus 2 into 2.5 means 2 into 2.5 means 5. 14 minus 5 means 9 mm. Okay, so surface area of the hemisphere also we are able to find the length of the hemisphere, right? Sorry, length of the cylinder we are able to find, right? Now surface area of the hemisphere is equal to 2 pi r square. We know the formula. Alage surface area of the cylinder is equal to 2 pi r h. Okay, right? Now, surface area of the hemisphere we are finding, that is equal to 2 pi r square. So r we know 2.5 mm, and this is 2.5 mm. The radius of the hemisphere is 2.5 mm, right? Okay, so the radius of the hemisphere is 2.5 mm, and pi value that we know very well, and we are applying the value here, right? After substituting the values, what did we get? We get 2 into 22 by 7 into 2.5 into 2.5, so 39.29 mm square. Okay, square millimeters we got. Okay, so there are two such type of hemispheres, one side and the other side. That is why we are there are two hemispheres in the capsule, no? That's why we are substituting, we are multiplying, the area, the surface area of one hemisphere into two, as we need to get two hemispheres area. Okay, so 2 into 39.29, we will get 78.57 square or square millimeters. Okay, so we kept this point at one side, right? And the surface area of the cylinder is equal to 2 pi r h. Okay, that is also a formula that we know. Okay, and we are substituting the values here. R is equal to 2.5 and h is equal to 9 all the units are in only, millimeters. Okay, so we are substituting the values. So after substituting, what did we get? 2 into 22 by 7 into pi value 22 by 7, we know. Or simply you can substitute 3.14 also. Whatever convenience you take, you can take. Okay, so 2 into 22 by 7 into 2.5 into 9. Okay, by substituting in the formula, right? So by simplifying all these values, what did we get? 141.43 square or square millimeters. Okay, so total area of the capsule is equal to curved surface area of the cylinder plus curved surface area of the two hemispheres, right? So we are able to find the curved surface area of the cylinder as well as the curved surface area of the two hemispheres. Okay, so we are adding now. So 141.43 square plus 78.57 square. So finally, what did we get? 220 or 220 square, 220 square millimeters. What is it? The total area of the capsule. Okay, the total area of the capsule that we get is 220 square. Okay, so how did we get? We get the total area of the capsule by adding the curved surface area of the cylinder and the curved surface area of the two hemispheres. Here we have taken the radius of the hemispherical part as well as the cylindrical part is equal to the diameter of the capsule, which is given in the information, because both end is stuck into. Okay, it is given in the problem, right? So when we are able to understand that particular point, it is easy for us to find the total area of the capsule. Just draw the picture and it is very easy for us to identify the required value. Okay, once again let us see the picture here, the capsule. Okay, this is the cylindrical part. Okay, and the hemispheres, both the sides. This is the cylindrical part and this is one hemisphere and this is one hemisphere. Okay, so when we are able to identify that the radius of the hemispherical part as well as the cylindrical part and as well as total capsule is equal to one another, then just we substituted in the values of curved surface areas of the cylindrical and hemisphere, and finally we added both of them. Okay, so I think you understood. Okay, thank you, and don't forget to subscribe.